Topic 2, we're going to finally look at factoring quadratic trinomials, but here's the catch. We're looking at factoring quadratic trinomials specifically where a is exactly 1. So remember, a quadratic trinomial is of this form right here. We know a can't be 0, otherwise it's no longer quadratic. But in these examples, a is going to equal exactly 1. Okay, so the factored form of a quadratic trinomial is the product of two binomials. You must know that. Okay, so when you have a quadratic trinomial, its factored form is always going to be two binomials. Okay, and that's going to be a key part of understanding the steps that I'm about to lay out for you. So because we know that a quadratic trinomial is going to be the product of two binomials when factored, we go ahead and just kind of set up two dummy binomials. And we're going to start each of those with an x. And this is true as long as a is equal to 1. Okay, when a is something other than 1, it's a different process for us. Now, once we start our two binomials, each with an x, we're going to look for factors of c that have a sum of b. So basically, find two numbers whose sum is b, but also has a product of c. Okay, so we're going to look for two numbers that when we multiply them, we get c, positive or negative, and then when you simultaneously add those numbers, you get b. So we're looking to make sure two things happen. We have to have a specific product and we have to have a specific sum, and signs are going to be an issue. So you do have to watch your signs very, very carefully. Okay, so once you have those two numbers that have the right product and the right sum, you just fill in the binomial with those two factors, and that's it. Now you can always check using the FOIL method. So I'll show you on the first example or two how to check with the FOIL method. And then after that, checking is going to be up to you. Now, I do want to point out, if there are not going to be two numbers that have the right product and the right sum, we would say that the polynomial is prime. We'll look at that later. Okay, so for example 2, it says factor each trinomial. So for part A, we have x squared plus 9x plus 8. Now, we're looking for numbers that multiply to give us c, but simultaneously add to give us b. Okay, so we're going to start breaking down c, the constant, as pairs of factors. Now, there's two ways to get a positive product. We can have a positive product when we multiply two positive numbers or when we multiply two negative numbers. Keep that in mind. So numbers that multiply to give us 8 would be 8 and 1, or we could have -8 and -1. We could have 4 and 2, or we could have -4 and -2. Now we're looking for the magic pair of factors that add up to be +9. Well, this pair of factors, -8, -1, that adds up to be -9. That doesn't work. -4, -2, if we add those, we get a sum of -6. That doesn't work. 4 and 2 have a sum of 6. That doesn't work. So the magic pair of factors that does work would be 8 and 1. Okay, so we would say that we're going to factor this as the product of two binomials. Each binomial starts with an x, and then we fill in +8 and +1. So +8 plus 1. Those are the two factors that when you multiply, you get c, you add, you get b. Okay, c and b being the coefficient of the linear term and the constant. Okay, now we can check this by FOIL. So check with FOIL. So I have x plus 8 times x plus 1. We're going to multiply the first terms. That gives us x squared. The outer terms is just going to be plus x times 1. The inner terms, plus 8x. And finally, the last terms, plus 8. And that simplifies to be x squared plus 9x plus 8. So again, we're looking for that magic pair of numbers that multiplies to give us the constant and simultaneously adds to give us the coefficient of x. Okay, let's look at the next example. So the next example, we have x squared minus 7x plus 12. Okay, so we're looking for numbers that multiply to give us 12, so I always start there. So I need a positive 12. That means I could multiply two positive or two negative factors. So I could have 12 and 1 or -12 and 1. I could have 6 and 2. I could also have -6 and -2. And lastly, I could have 3 and 4 or -3, -4. So let's go through and add up each pair of numbers. Well, this pair, 12 and 1, when I add them, I get 13. 6 and 2, when I add them, I get 8. 3 and 4, I get 7. Negative 12, negative 1, I get negative 13. Negative 6, negative 2, I get negative 8. And then negative 3, negative 4, I get negative 7. And we're looking for two numbers that multiply to give us 12, but add to give us negative 7. So we're going to use negative 3 and negative 4. So I have x and x, starting two binomials, both with an x. That's going to give me the x squared when I FOIL. And then I'm going to fill in the remaining factors as negative 3 and negative 4. Now, it does not matter which binomial you put the negative 3 and which binomial you put the negative 4. I could do x minus 4 times x minus 3. It's going to be the same because multiplication is what we call commutative. It means we can rearrange multiplication. It doesn't change anything. However, the sign in front of the factor matters. These both need to be negative. So x minus 3, x minus 4. Okay? And just like before, let's go ahead and check one more time with FOIL. So I have x minus 3 times x minus 4. I'm going to multiply my first term. So x times x is x squared. Outer terms is x times negative 4 or negative 4x. Inner terms is negative 3 times x or negative 3x. And last terms, negative 3 times negative 4 is plus 12. And this all simplifies to x squared minus 7x plus 12, okay? So just make sure you understand what you're doing here. The final factored form of each of these binomials, or each of these trinomials, is this product of binomials. So those are your final answers, okay? And just know that if the constant is positive, you can have either two positive factors or two negative factors. We've seen one of each here. Now let's look and see what happens when c is negative. Okay, so for part C, we have x squared plus 3x minus 28. So we're looking for factors of negative 28. That means one factor has to be positive, one factor has to be negative, and we want those factors to have a sum of positive 3. So that tells me the larger factor is going to be positive, but let's just go through it. We could have negative 28 and 1, or 28 and negative 1. We could have negative 12 and, not negative 12, negative 14 and 2, or 14 and negative 2. 28 is not divisible by 3. 28 is divisible by 4, so we could have negative 7 and 4, or 7 and negative 4. And I think that's it. And if you ever start to doubt yourself as to what your factors could be, go to the calculator. And this is a little bit time consuming if you really aren't up to date with your multiplication tables, but it works. So we know that we're looking for factors of 28. So we would go 28 divided by 1, we know is 28. 28 divided by 2, if you get integers, play around with the signs and see if that's a factor. 28 divided by 3, we get a decimal. That's not going to be a factor pair. 28 divided by 4, we get 7, so we get integers, so we know that's a possible factor pair. And then you could keep going. 28 divided by 5, decimal doesn't work. 28 divided by 6, decimal doesn't work. And then we get 28 divided by 7, so our factors are starting to repeat, so we know we found them all, okay? So go through, just do whatever your C is, divide it by integers. As long as you get an integer answer, it's a possibility as a factor pair, and just try out your signs, okay? Now let's go back to the worksheet. Let's add up all of our factor pairs. This becomes something that you can do generally quickly in your head. I'm showing you kind of long and drawn out just to make sure you understand where these factors are coming from. But let's see, negative 28 plus 1 is negative 27. Negative 14 plus 2 is negative 12. Negative 7 plus 4 is negative 3. 28 plus negative 1 is 27. 14 plus negative 2 is 12. And finally, 7 plus negative 4 is 3. This is our magic pair. We want the pair that multiplies to give us negative 28 and simultaneously adds to give us 3. So the constant and the coefficient of x are really, really important numbers. All right, so our final answer, we get two binomials, each starting with an x. That way, if we were to FOIL, we would get that x squared term. And then we just want to fill in the two factors that we found here. So plus 7 and negative 4. You could do x minus 4 and then x plus 7, same thing, okay? As long as you get the two factors in there with the correct sign, okay? Let's go ahead and look at part D. So in part D, we have x squared minus 2x minus 15. So that means we need two factors of negative 15, one positive, one negative, and they have to add to -2. That does tell me that the larger of the two factors is going to be the negative one, but let's just go ahead and work it out. So I've got -15 and 1, or 15 and -1. I have -5 and 3, or 5 and -3. Let's check our signs. So, or let's check our addition, I guess I should say. So -15 plus 1 is -14. That is not -2. -5 and 3 is -2, but let's just double check the next two to make sure we're good. 15 and -1 is 14. 5 and -3 is 2. So -5 and -3 really is the magic pair. These two numbers, when I multiply them, I get -15. When I add them, I get -2. So my final answer, two binomials, each starting with an x, and I want to throw in these two factors here. It does not matter which factor you do first. I could go +3 -5, and that's my final answer. So just make sure you understand you're looking for numbers that we multiply to get the constant. If it's a positive constant, the two factors have to have the same sign. If it's a negative constant, the two factors have to have different signs. And whatever factors you choose have to add up to be the coefficient of the x term, okay? So make sure you practice this. Get a little practice with multiplication tables. It's not going to hurt you at this point either.